I'm Stephen Foskett from Gestalt IT, and we're here at AWS reInvent. If anyone has been following the news in technology lately, there's so much talk about what's going on in the custom silicon world. It seems like every cloud vendor is coming up with their own Arm chip. Many of them are coming up with their own AI processors. And this has been a subject that I've heard quite a lot about from the 6.5 with Daniel and Pat. So welcome to the show.
Yeah, it's great to be here. This has been a topic, and it's not really new or surprising, but it definitely seems to be picking up steam.
It sure does, but it's a little confusing, isn't it? Because at the same keynote, they're introducing an NVIDIA-powered supercomputer, and they're also unveiling the Trainium.
Yeah, it's an interesting sort of inflection and almost a challenging moment, if I may say, if you're Jensen Huang. Because you're Jensen Huang and you're on stage celebrating your AI factory, and you're up there and you're talking about it, and remember, AWS didn't immediately get on board with DGX Cloud. They waited, they watched. There were some that were suggesting because of the homegrown silicon and its own strategy and lack of money to be made, that they just were never going to do it. And then it was kind of, pivot, 180, all of a sudden Jensen's up there. But then, Jensen kind of walks off the stage. And then, I think it was two slides later, and we have trillion parameter models that we can also train on our brand new, very efficient, high performance, lower cost, better economics, Trainium 2 chip. And you're going, and if you're looking at this from afar, you're saying, okay, but I'm going to give you the explanation now. AWS has been born as a company that's set and serving the customer and meeting customers where they are. AWS is a company that has always had a variety of offerings. When it was just merchant, it was all the Intels, all the AMDs, and over the years, it's had all of its NVIDIA instances for AI. So the pivot really is this inflection that's more of the industry inflection, Stephen. So you talk about this inflection of the industry where, yes, vertical integration is a part of every company's story. They want to do more revenue, and they want to make more money on every dollar. You know who does this really well? Apple. Why did Apple go to ARM cores? Why has Apple changed its entire strategy on Mac, and it continues to build more silicon? AWS is seeing the same thing. It's not that they don't like Intel. It's not a personal vendetta against NVIDIA. They're just saying, look, if you want NVIDIA, you can get it here. But we also have built a really high-performant, very power-efficient piece of silicon that can do training, or in some cases do traditional computing. So it's an interesting evolution that we're watching, but I don't think it's these two companies are like butting heads. I think we're co-opetition, and we're both going to do what's best for us, and that's what we're seeing here.
Yeah, I agree with you. It seems like Amazon is trying to cover all the bases with what they're offering here. They want to make sure that whatever the customer wants, they have. And we saw this before. So in our talks with AMD at Cloud Field Day, for example, AMD is very proud of what they've been able to deliver in terms of x86 processors for the cloud. And we just saw a phenomenal report from Google that shows the benefit of AMD's many cores in cloud computing. And you can get AMD instances in AWS, or you can get Intel instances in AWS, or you can get Graviton instances in AWS. And I think that it shows that Amazon is just trying to make sure that whatever the customer wants, the customer can get. Beyond Amazon, though, we have to ask ourselves, is the inherent performance advantage of something like an ARM core, let alone, we can talk RISC-V too, but let's start with something like a Graviton.
Remember, ARM is RISC. ARM is RISC. It was the original RISC. It was reduced instruction set.
Yep.
People sometimes forget that, though, because you're hearing about open source and RISC, but ARM has just become the sort of proprietary RISC. Mm-hmm. At this point. Sorry,
No, you're right. And I think that that's really important because the evolution of RISC has, they were all RISC for a while. I mean, my background is in Unix systems. I mean, PA RISC and Spark, MIPS, they were all part of that same wave of RISC that gave us the ARM instruction set. But, even when we look at what's happening on the ARM versus x86 side, there's a compelling argument to be said that Amazon's Graviton gives you more bang for the buck, but yet they're still selling a heck of a lot of x86 instances. And there are reasons for that. Similarly, with the latest information that's coming out, I mean, you could say that AMD is really killing Intel in terms of x86 performance per power per dollar, but yet customers are still choosing Intel. In fact, if you look at the supercomputing 500 list, Intel pulled a little bit ahead this time. So there are reasons that people go with things that go beyond performance. And I think that this is one of those things that colors this whole discussion when people are saying, oh, ARM is going to kill x86. I don't think it is. I think it's like you were saying, it's about options.
Yeah, there's an option viewpoint. There's also a market size viewpoint that has to be brought into consideration. You know, our intelligence team does a lot of market intelligence, and we're looking at, you know, the evolution and growth. And, you know, you're talking mid double-digit AI growth for, if not more. I mean, again, we're seeing this weird sort of training boom, and the way AI is being bought, it's only a few companies that have all the density. Deployments are very small, and right now, part of the reason you're seeing some slowing in parts of sectors is because now people bought all that equipment, now they're deploying it. You heard Cisco guided down their forecast for exactly this reason. They're like, yeah, we sold a ton of stuff, but now people are trying to implement the networks that can support all this AI. So the strategy as it pertains to how you know, companies will decide, it's kind of like a car. You know, you could say, well, Tesla built the high performance Model 3 for $38,000 plus some options. You can get a car that's faster than a Ferrari. Does this mean no one will ever buy a Ferrari again?
But people still buy them.
People still buy Ferraris. And, you know, it's like utility. It's like, well, maybe I need a truck bed, so I need a bigger option. Maybe I need to carry my 7-seat family. Maybe I don't like the way the Tesla looks. And there is, it's not a perfect analogy. But the bottom line is there are many silicon variants that can do similar jobs for similar purposes. And you got things like performance and latency. You've got also things like provenance of what you've had on your system. Like Intel has a lot of provenance that exists inside of enterprises. And you can ask AMD, even over almost a near decade where Intel didn't get a lot right, they still hold the vast majority of market share. And why is that? Because refactoring all those workloads and moving from one piece of silicon to another, even x86 to x86, did not take zero work. And so when it's a heavy human lift to move from one system, one piece of silicon to another, companies said, you know what, we're going to stick with this because, you know, if there's a 0.0003 second latency difference from one instance to the next, we're not going to get out. So to your point, I think it's an and. So I started talking about market growth, and I kind of got off into this this analogy. But the thing is think of how much more silicon. Every car went from having a few hundred odd chips to a few thousand. You know, a new system, they have FPGAs, they're going to have accelerators, they're going to have CPUs, they're going to have GPUs, they're going to have IPUs and VPUs. And what I'm saying is the number of chips per piece of hardware means that the total TAM, the serviceable market, the total market addressable by these chip companies is substantially larger. So even if Intel doesn't gain share, they can still grow. And people don't ever factor that in.
Yeah, absolutely. I think that there definitely is going to be a battle between Intel and AMD,
yes,
because that's always been there and it'll always be there. But the battle between ARM and x86, I think, is maybe a little overstated, because I think that it's basically, it is analogous to an electric car versus a hybrid or versus a conventional car or something. There's reasons that you would go in one direction. There's reasons you would go in another direction. But when you mention embedded processors, I'm sorry, we got to talk about RISC-V. Because one of the reasons that companies like Western Digital have adopted RISC-V is because of the fact that there are so many of those processors. They don't need all the features, and they want to have a very special custom processor. And there's financial reasons to go with RISC-V.
Yeah.
And then there's China. But RISC-V, do you think that that's going to have much of an impact, or do you think that that's a bridge too far?
Well, I think it's all about the ability of these companies to write to the ISA. They can actually modify RISC-V silicon to their exact parameters and do it very cost efficiently. Mm-hmm. That's not as much of an option anymore with ARM. ARM has a much narrower set. There's very few architectural licenses that are being given anymore, and the companies that can do that tend to be massive, you know, like Apple. I mean, it just doesn't exist. So RISC gives lots of flexibility, lots of openness. It's kind of like what ARM was like 12 years ago, in the sense of like, they're the company that people are now turning to, saying, this is kind of this unique need that I have. Can you help? And of course, in very low power, edge use cases, IoT, even automotive, you see there's a lot of applications for RISC. The interesting question, though, is, and I think it's happening, by the way. I mean, you know, there's a feud going on with Qualcomm and at ARM right now. And you'll hear little rumblings, you'll hear little comments of, well, somebody just takes the right company with the right motive and the volume and to go over to that risk community and say, we want to try to build a PC, or we're going to build a phone. And, remember when Apple first went to Arm? And everyone's like, no one's going to buy these things, man. How are you going to go away from Intel? They are. And then, you use the M1. It was a little sketchy at first. I don't know if you used an early M1. It was, some of the emulations, some of the apps, it was terrible. But long story short, by the middle of Gen 1, it was really good. And I'm not an huge Apple fan, but I'm saying I have a Mac and I have a lot of other devices. The M2 is pretty awesome. And all I'm saying is, and then there's a period now, you know what? The people that are in the Apple tribe, Stephen, they don't even think about it. To them, Apple's just one vertically integrated creator of experiences, and they've completely moved people away. So it's entirely possible, if it moves beyond this kind of very technophile area of interest, to just use cases.
Yeah, and I think that there's two insights in there that I want to pick out and say you're 100% right on a couple of things. Number one, when you talk about Apple, you're talking about vertical integration. That translates very well into the IoT space. And that's, I think, one reason that we're going to see a very quick move to adopting RISC-V processors all over the place that aren't the sort of signature CPU use cases. Because it's vertically integrated and no one will know if they switch to RISC-V. In fact, I have it on good authority that we've already got RISC-V chips in production in some of our consumer devices that people just haven't noticed yet because nobody cares. The other thing that I want to pick on there is when you think about vertical integration, there's also, back to the beginning of the conversation, the analogy about inferencing and training of AI models. And there, NVIDIA is obviously, people can't buy their stuff fast enough. They can't produce as fast as people are buying. Everybody loves what they've got. They've got, CUDA, which has the most amazing ecosystem. Is there a chance of anyone bumping NVIDIA off the top of that heap?
In the near term, no. Very straightforward answer. Having said that, there is programming and developer evolutions that are taking place and layer of abstractions that are changing. It used to be all about CUDA. And you're seeing the layer of abstraction moving up the stack, Python, PyTorch, JAX. And as you move to different developer ecosystems, and CUDA, the libraries become less essential, and you've got new libraries being developed outside of CUDA, and the optionality. Because remember, 2 years ago, Jensen was like, this guy's crazy. It's a gaming company that's this little data center business. He bought Mellanox. People were like, okay, maybe this works. And then all of a sudden, it flipped, and this is it. And by the way, every great company and every great invention had a period of time that the world's sheep didn't realize what was going on.
There's no revolution.
So you're being a little bit crazy. So I give them a lot of credit for that. But having said that, with these kind of evolutions taking place and these layers of abstraction changing, you look at ROCm, you look at what they're doing at AMD. Actually, I'll be with Lisa Su next week, and there isn't going to be no competition forever. First of all, the Annapurna team, I spent time in their lab. What they built with Trainium and Inferentia is a very impressive product. What AMD is building is impressive. Gaudi, we've tested and seen some of the results. It's not great on every workload like a GPU, but the last thing, and I know we've got a roll, so I'm going to silence myself, but as we move from the era of training to the era of inference, the kind of what silicon is being used for inferencing my workload, I think this is the same thing we saw with how Graviton ended up getting market share, is that people are using AI in the cloud on their Salesforce app. Nobody's when they buy Salesforce, is the genie I'm using to optimize my sales flow running on an NVIDIA chip? They don't care. And so as long as they don't care, it could be a Google TPU, it could be an ARM, it could be an accelerator on an ARM CPU, it could be a lot of different things doing an inference activity. And so competition will grow, and NVIDIA's margin is going to have to get squeezed at some point. This 1,000% on an H100, that cannot last.
Yeah, 100%. And I agree with you there as well that we live right now, we are in the training era.
Yes. And
we can't buy enough of it. We were going to continue buying training chips, but we're soon going to move into an era where inferencing is king. And that, as you said, with the advent of PyTorch, with things like Intel using the Gaudi IP in other places, with Grok, with Amazon's proprietary stuff, and frankly, with the stuff that companies like Arm are developing and AMD and their Instinct, I think that there's a huge market opportunity for the next generation of inferencing chips, and I think it's going to be massive. Well, I really appreciate you sitting down with me. You have the kind of insight into these things that I just don't get because you talk to Jensen and Lisa and so on, and I just read about them. So thank you so much for this conversation and sharing that insight with me. As I said, a big fan of what you're doing with the 6.5 with Pat. It's a great source of information for us. And of course, I thank everybody for watching. If you enjoyed this conversation, check out the Gestalt IT videos on YouTube, Gestalt IT Video, or gestaltit.com, or find our weekly news rundown in your favorite podcast feed.